Our next finalist is Jessica Swetish from the School of Earth Sciences and Environmental Sustainability. Her major professor is Dr. Deborah Hunsinger. Jessica's presentation is entitled Benchmarking Models for NASA's Carbon Monitoring System.
The climate is changing. It has changed many times in the past, and it is currently changing today. The most recent changes are due to an increase in atmospheric CO2, mostly due to anthropogenic or human-based inputs such as burning fossil fuels. In current conditions, about 50% of the CO2 that's been emitted has remained in the atmosphere, while the additional 50% has been taken up by the ocean and land plants. Land plants take in CO2 mostly through plant photosynthesis. Plants open their leaf pores to breathe and take in CO2 as food. But exactly how much CO2 is taken up by land plants, and what is the spatial distribution of this uptake? Can someone go around and measure this? Definitely not at the global scale. Instead, we use models. And these models are called terrestrial biosphere models. So, oh no, I said the word model. So now everyone's thinking, well, how do we know that these computer models are even accurate? Well, we do this through benchmarking. So in general, to benchmark a model, we first plan. We plan an aspect of the model that we're going to evaluate. We then, too, compare. We choose an observation to compare the models to. This then gives us 3, a score, or an assessment about how well the models compare to the observations. And this can, 4, be used to guide model improvement. I'm using a unique method of benchmarking models against satellite observations. Satellites offer good temporal and spatial resolution. They're always up there orbiting in space. They eventually will pass over every single point on Earth, and they pass over the same point about every 3 days. Benchmarking terrestrial biosphere models with satellite observations will allow me to create a new best model by benchmarking a group of models and then deriving a weighted multi-model mean. This new best model can then be integrated into a large national project, NASA's Carbon Monitoring System, or CMS. NASA's CMS is a data assimilation system that acts to connect scientific data with the scientific data with the policy and decision makers. It has the ability to consolidate and translate this data into a way that's easily accessible and easily understood by the policy community. Overall, my research will demonstrate a unique way for assessing terrestrial biosphere models by using satellite observations, and will ultimately create a new best model for NASA's CMS. This, in turn, will create more accurate data that can be transferred down the line to decision makers who wish to use this data for various forms of environmental and carbon policy. Thank you.